Today is day 5. I applaud all of you guys for coming every consistently to day 5. Look forward to much more to come. Alright guys, so today we'll be first looking at our homework from last class. So let's look at the first problem here. So the first problem asks us to essentially find a range between a list given. Essentially what a range is the maximum value minus the minimum value. And then this also tells us how we should be inputting the list. This tells us that we want to have our numbers separated with spaces. Okay, let's try to solve the problem. Okay, let's first create a class. Let's call it find range. And then since we know we will be inputting a list into it, let's also add that. Let's just call it number list. And then we want to find the maximum and minimum value. Let's do that also. Okay, right now what I just did, so I just called a variable called max value, and then I just used the max method to find the largest number within the list. And then I just want to create like the same thing for the minimum value as well. After that, since I found the maximum and the minimum value, I can find a range by subtracting the two. And essentially, I want the max value to minus the minimum value. Okay, so now I've created this function. Let's look at creating this list. Let's call a variable called list, shorten. We know that from our class description, from our homework description, we want to actually create this list through an input. Let's do that too. Okay, but this problem also tells us that we want to have the numbers separated within with spaces. So therefore, when we want to actually get the numbers, we need to use something we taught last class called split. Essentially, what the split does is that it just splits characters of strings and put them into a list. But in the process, it removes the character that you don't want. So in this case, we don't want is the space. And then we would do split as well. Okay. So now we've created this list with the right criteria. Now we want to actually get the numbers only, right? So, but essentially what this is right now is that this just plays all the numbers into a so this just plays all the numbers into like a string form, but we cannot do subtraction with string. So we must change all the characters into integer form. So when we can do that is we can just iterate through the list using a for loop. For I in range zero to len list. Okay, so this essentially I have it at the 0 to len list because we know that essentially what this will give is from 0 to the length of the list. But this does work because we must remember that how the identification works is that it goes from 0 to 1 less than that. So this will work perfectly because we know that when we have range from 0 to number 5, it will go 0, 1, 2, 3, 4. So this will work perfectly. Now I've completed this. Essentially, I have not completed this. Okay, so now I've completed this. Essentially, what I'm telling this to do with this for loop is to tell it to iterate through the string characters and convert each one of them into an integer. So now with all that being done, I can finally call the method find range. Now let's try it. This is great. So this gives us, I inputted three characters, three integers, 1, 2, 3. And I know the largest is 3 and the smallest is 1. So then this gives me the range of 2. Boom, problem 1 solved. Please post all your questions in the chat and our TAs will get to it. Okay, now we look at the second problem. Second problem tells us to take in two lists of numbers and return the sum of every possible combination of products between the two lists. And specifically, I guess for details, we're looking for all possible combinations. So like it doesn't have to be unique combination. For example, essentially for us, we're counting 1 times 4 is 4 and 4 times 1 is 4 as distinct. So let's try this again. So okay, let's start on this problem. Okay, let's first again define a class. So let's call it definition find sum of all products. And remember guys, we're entering two lists, excuse me. Actually, what I've done here is to create a nested for loop. Because let's look at like our homework example. We want to find every single combination. So what I'm thinking we can do is that we can have the first list. We can use the first list to find its first, and then find its first integer to then multiply with every integer on the second list. Then we're guaranteed to have found every single possible combination, non-unique combination. And that's something what I'm doing here. So I'm looping through the first list only when I've gone through the second list, every single character. Try. So same thing I'm doing here. I'm just going to be entering the list of numbers by separating the numbers with a space. So essentially I can take it out as explained in the last example by using the idea of split and entering a character, the space within split, so I can know, so I can try to find what string character to remove. And this function requires two inputs. So that's why I'm creating also like one other list as well. Gives us 54. So we know this. So now we see like this program actually running. Again, please leave any questions you have to the chat, and we will see if we can help all of you. Okay, so with that being said, let's begin today's lesson. So today's lesson will just be going through like the details of specific things you guys could be using to maybe make your lives easier, and then ending up like our portion of Python. Okay, guys. So the first idea like I need to be introducing to you is the idea of methods and functions. Methods we can see is, for example, something like s.f. Essentially, what we do is that we call this idea of we're calling the method, we're calling the f method on s. That's how we would say s.f in this case. And one thing really important about methods is that methods are is dependent upon a class. So you cannot call it by itself. So we know that something is a method when we're entering something into the method, or more easily spotted, we can see that methods are usually goes under a class. And then we see and a function on the other hand is something like length. So this tells us the length of s. We can call this action by saying we're calling the function length on s. And one important fact about functions is that it is independent from a class. So we can't call it by itself. And as a result of the difference between methods and functions, we can see that methods and functions are not interchangeable, and using it wrong provide errors. Let's look at some examples. Let's take an example of s equals, this could be any string. Very funny. Then we look at the idea of print length.s. So this is a function. But then we look at s.upper. When we often have this idea of dot something, we can just quickly spot that this is a method. And something more complex could be s.replace, where we have inputting two strings rather than one. Okay, next we look at classes and instances. Classes can also be considered as types or data types, as we learned earlier. For example, some classes could be integers, strings, float, or booleans. And instances are specific values of a given class or type or data type. For example, ABC is an instance of a string, and 123 is an instance of an integer. These two things are kind of important. Okay, now we move on to the idea of objects and object-oriented programming. So essentially what all you guys have been learning up to are the details of object-oriented programming. And with those skills mastered, we look at the whole idea. No, we look at the large idea as a whole. Okay, so objects in Python includes your all values, all instances, and all classes. And classes in Python are all types. And let's break it down. So values, we're talking about 1, 2, 3, 4. And types are type of data stored in objects or variables in the program. These type of integers, strings, and floats are type of a type. Then we look at instances. Instances are essentially variables referring back to a class. Let's take a look at this picture right here. We see that the class is called person, and we're able to call the class person by assigning it a variable, in this case P1. So then we can say that P1 is an instance of of the class person, which means that when we're calling P1, we're referring back to the class person. And classes, as a general, is just some organization of code used to solve a problem. So, long story short, everything is an object in object-oriented programming. Now, we move on to the next idea of writing classes. This is an important skill you need because to be able to carry out object-oriented programming, you need to be able to refer back to classes, which is what we're creating now. Essentially, to create a class, we need two things: naming the class and creating a constructor. Now let's move on. Now I'll be demonstrating to you this class called dog. Okay, so to begin writing this class, let's define a class as my instruction has described. So let's call it dog. Then one important thing of this is to initialize this. So it's essentially we're telling them what we are putting into it. So we can do that by calling this initialization constructor. So okay, so here what I've done is to create this initialization by creating this definition idea. So this is what we call a constructor, and I'll be calling this constructor from now on. So looking in this constructor, I have created two variables, instance variable, that being of name and age. So we can actually, so when somebody enters the word name and age, we want to be able to store it. That's why we can have self.name equals name, and similarly self.age equals age. So now we have found a way to actually store this thing. So now let's try it out. So now let's create an instance called D1. Let's call D1 dog. Let's have the variable D1 refer back to the class dog. And we're going to be inputting the two variables as explained before. Let's call it dog and apple. Okay, so this ran. But now we want to access the variables. We can do that by using the print function. Print d1 dot name and d1 dot age. Let's try what it says. Okay, great. This tells us apple 4. So now we know that our class did work successfully because we're able to access the different types of variables stored. Now let's verify the type of instances. So one thing we can do, because previously we talked about types, and I can show you an example of type right here. So let's print the type of d1.name. Let's think about it, guys. What do you think d1.name, its type would be? Could it be a string? Could it be an integer? Well, let's find out. d1.name. Well, this is a string. Well, notice how this says the word class here. Let's go back. This tells us that all types are classes. Now we've connected the two ideas together. Boom. Okay. Now let's just say, what if somebody wants to, for example, change the name of D1 perhaps? We can just do D1.name equals, what do you think a good name is? I think dot could be a good name. So let's try dot. And for experimental reasons, let's try printing it out again. Boom. So this tells us dot 4. So we know that now we know that the name has been changed successfully. That's great. So now we have an idea of how to create a class and how to use a class when we have created a class. Perfect. Now we move on to the idea of creating methods. Notice how we're not able to do anything specific here, but rather than just access the variables. But when we have more difficult things, we wanted to do something. That's where methods come in. So essentially, methods are your task completers. For example, let's look at this code. We see that we have the constructor right here, same thing as we've done before, but we see this idea of this, say hi, and inputting dog. Could you guys maybe think about it? Why could this be a function turned into a method? This is because we have placed the dog variable into the function say hi. Then this will then satisfy our definition of a method, which requires the dog to be inputted. Then say hi will be called, which then tells us that say hi is no longer independent. Okay, now let's try what this will actually say. Let's go back to our class dog as we've previously done before. So because we want to say hi, let's just create like a fun sentence. Why not say, "Hi, my name is X and I am X age." How about that? Let's try that. So now let's try to print it. Okay. My name is Dot, and I'm 4 years old. And this will then match our previous understanding of changing the name from Apple to Dot, and then while leaving the idea of for the age being the same. Great. So now we learn how, how to write a method. Moving on, let's discuss and break down this example. So this is a car class, and then we have the constructor right here. This tells us that we're entering the two variables model and year made, and then we're again storing the variable model here and storing the variable year made here. So now we have a method. We're entering the word. We're entering like the variable time here. Okay, so essentially what we can do is that we can then print it and say self.model says word.times. So then when we print it, we can say when we print it and enter the variable time in, we will get something like this. 2023 Toyota Highlander says where. So essentially, like the times variable tells it tells the program to print how many times the string word. Great. So now I have a progress check for you guys. So write a car class that has the following instance variables: year made, model, and seats. Then create a method called by, which outputs the following after you call it on an object. The 2023 Highlander with 100 seats has been sold. After that, create an object and input any data for each attribute and run the by. Cool. So I'll give you guys about 15 minutes since this is a longer progress check. And update us on your progress within within the class chats. Thank you very much. I'll give you guys about until nine. Yeah, until 35. Seems like most of you guys are making great progress, and it seems like lots of you guys are getting it. Okay, so I'll be sharing the solution right now. So again, we're creating like a class called car, and that's what I've done already. Again, our first step is to initialize, and to create our constructor. Okay, so we're calling self, and our variables are year made, model, and seats. And then afterwards, we're trying to store the variables that we got. We want to create a method called by. Now let's just say that we want to print something as well. Now let's create an instance. Got it. Okay, so now we know how to create a class. We also know how to write methods. Now we also know how to write a we also know how to write a method. So essentially, we have gotten the majority of idea of object-oriented programming. And to help you guys understand why object-oriented programming is important, we look at the following. First, we look at abstraction. So essentially, it hides the underlying complexity of code, which makes it easier for the readers to understand and to grasp. Then through the methods, it makes it easier for other code writers to use the method without having to know exactly what it does. Then the second idea of why it's so important is encapsulation. So it organizes the code, and it promotes intuitive design, and it restricts access. And the third idea of why it's important is the idea of polymorphism. So different classes can have the same method name, and an outcome will be based on the object's class. So polymorphism, as you will see in the next few slides, could be very, very helpful. And the fourth is idea of inheritance. You can create a child class, a class that inherits the parent's class features, attributes, and method. So this allows for code reusability. So essentially the difference between polymorphism and inheritance is the idea that you can, in polymorphism, if you call, you can call one thing and then two things can show up. While as inheritance is the idea of that you can have one thing and then create multiple other classes. You guys will be able to see more examples in the next slides. Okay, so now we're going to talk about the idea of objects and aliases. So essentially, when you make an alias of an object, it will point to the exact same object. Let's look at this code. We define a class called person, and we initialize it with a variable name. So we first have the first instance variable called person1, referring back to the person class and inputting the word Timmy. When person2 equals person1, and we call the name, but we change the person1's name to Jake, person2's name will change as well. So this is the idea of aliases. So when the original change, the new one will change as well. Next, we have the idea of polymorphism. So right here we have two classes. One class is called dog, and the other class is called cat. So let's look at the dog class first. We see that this has the method called speak, and then we're printing wolf. But for the cat, we're printing male. But let's look at this. So for animal is just an instance in both the class dog and cat, and we print and we call the method animal.speak. So let's see what happens, guys. This class dog. For animal in both dog and cat. That this prints wolf and male. So we see that the idea of polymorphism is that when we have one call, and given how many things we are morphing from, we can see that this will dictate how many results come out. So right here, we see that we're making one call, animal.speak, but we're morphing dog and cat. Therefore, we have two things, wolf and male. I can give you guys another example. Let's say we want to create another class called snake. When you try to do polymorphism, always remember to put all of your classes within the one call. Great, so now we see that this prints wolf, meow, and the sound of a snake, possibly. Great, so now we see that when we have one call in polymorphism, you can get as many results as possible given the number of inputs you have right here, and also that you have to call the same method as well. Okay, great, let's move on. Okay, next is the idea of type testing. You guys have already tried type testing when you guys were already learning about 2D list. Essentially what this is that this zero variable tells us the row, and then this variable 1 tells us which column it is. And we can try this, of course. It's 3. So this tells us this is row 0. So this is row 0, and this is column 1. So this gives us 3. Great. So now we have learned typecasting, which allows us to get one specific character out of a 2D 2D list. Now, what if we want to be able to look at each individual item within the 2D list? We can again use some things we have learned before. For example, these for loops. So breaking this down, this tells us that we can iterate through each character by looking at the number of rows and the number of columns. Okay, essentially what this special method does is that it increases every single integer in every single position by 1. So this, you're able to go through every row and every column and to increase every spot by 1. Essentially, this just tells you guys that you guys are able to create lots of very interesting things by just using and combining your knowledge that you have learned. Now we move on to the next important thing of inheritance, which is a mechanism that allows you to create a set of classes that share the same properties and methods. Okay, we can look at this. Let's break this class down. So our parent class, as we call it, is the idea is person. Just think of basic biology that the children class will share some characteristics of the parent. So looking at the parent class, we always initialize the constructor. So we have the variable name and ID number, and we just store that ID number right here. Then we look at the child class. We call it class employee person. Essentially, this tells it that we're looking at inheritance from the parent class because we're entering this into the employee. So sharing similar idea of the understanding of a method, we're then clearly seeing that employee depends upon person. And of course, just like any class, we should initialize this. We could, in our initialization, we have the variables name, ID number, salary, and post. Notice that the initialization name and ID number comes from the parent class. So we could just only initialize salary, like salary using itself, but we could invoke the initialization of the parent class by calling person, which is the name of our parent class, initialize name and ID number. And after all, we're then able to access again all of our different entries. I can demonstrate this to you guys again. Sorry, I can demonstrate this to you guys. Okay, so let's just run it and see what happens. Okay, nothing happens right now. Okay, no problem. So print a dot, let's just say name. Okay, so great, this prints Ravol right now. But let's see what happens when I remove the invoking from of the initialization from the parent class. Right, so we see that the idea of name has no attribute to employee because we have never actually invoked like the storage of the variable name that we're passing in. So then, which means we cannot access it later. That's why we need to have this invoking so we can keep accessing it. Great. So now let's move on. So similarly to the idea of a children and parent relationship within basic genetics, we see that children can have other properties that the parent doesn't. So similarly in coding, child classes can take on additional properties. For example, to call a property, simply use the dot notation. Okay, let's give this a try as well. Okay, let's break this down. So we see that this has a class person, and then we're again defining the variables name and age. But then we have this method called display, which gives us the name and the age. And let's look at the child class. So this again directly inherits from person as seen here, and this has a new idea, that being of name, age, and job. Okay, let's call this. Oh, okay. Oh yeah, never mind. Okay. Okay, great. So this does give us the actual variable, give us a name apple. Let's try Dob. Okay, great. So now we see that we can also access the different variables within apple. Uh, within apple, we can get the name and the DOB as well. So I think date of birth can be, DOB stands for date of birth, but you get the idea. Okay, so today is your free day. We have no homework today, but please post any please post any questions you have in the chat. I think today we are done. So thank you so much for coming to our class today. We truly appreciate your attendance. We look forward to seeing all of you guys on Friday. Thank you so much.